So these notes, so I use this guy, Brian Passwater. A lot of, I would say most AP pre-cal teachers across the country right now are using his materials. They're fantastic. If I ever feel like, I need to add something to it, then I'll probably pull from the textbook for that. But he's making really great, kind of short, sweet, to the point notes. Really good activities for us to kind of practice together as a group. You can think of those as examples. And then his homework's pretty short as well. So I kind of like this stuff. And formatting's nice and neat.
Teachers, please pardon the interruption. At this time, if you'll go ahead and release the band to the tiger pit. Thank you.
That very first blank up there, and you guys just read over to know the drill, is a function. A function is a mathematical relation that maps a set of input values to output values, so each input value has exactly one output value. That's a lot of words to say. When you plug in an x, you get out a unique y. That's a function. You have learned to use the vertical line test to determine if a graph is a function or not. That doesn't always work as you get more advanced into mathematics. So more on that later. When you're plugging into a function, those are like your x values. Everything you plug in, your input values, are called the domain. And that's going to be represented by the independent variable. If we're working on an xy plane, you can think of it as x. When you plug in a value and you get an answer, the output values create the range. And that's going to be represented by the dependent variable. Let's look at these examples really quickly. Example B is going to be super duper easy, but it says, sketch a graph in this domain. Notice that's input values, x values. So x's are from -4 to 4. For the function rules below. Function rules can be represented by just words. You could have an equation. You could have a table. So the rules are just essentially the description of the function, and you need to be able to graph this. So A is kind of keeping things just in terms of words here. It says the function halves each input value. You can read that as every single x I plug in, I'm going to cut it in half, and then I'm going to add 1 to it. So there are lots of different ways you could tackle this. If you're really good at writing equations, which probably you're thinking I'm not, but watch how easy this is. For every single x value I plug in, I take half of that x value because it says the function halves each input. Input is x. And then adds 1. And that's how we come up with our function f of x, which we'll figure out with just y equals 1 plus 1. Well, now I see this and I realize that it's linear. You should be able to look at this and realize it's linear, mx plus b. How many points do you need in order to graph a line accurately? What's the bare minimum? 2 points. Well, then how about we just plug in -4 and +4, and we'll have our 2 points. We can connect the dots and move on, okay? So what is 1/2 of -4? -2. And what's -2 plus 1? -1. My input is -4. My output is -1. That creates the ordered pair -4, -1. So graph. Now let's use 4 as our input value. Essentially, let's plug in 4. And I'm not a teacher that's going to make you show work. So if you know, hey, half of 4 is 2 and 2 plus 1 is 3, and you just want to graph the point, fantastic. But if your input is 4, your output is 3, that creates the ordered pair 4, 3. And then you can just connect the dots. This is a linear function. It says sketch a graph. There it is. B is going to seem so much easier and less mathy than that. All we have is a table of values. We have 1, 2, 3, 4, 5 ordered pairs. Graph those points. Do not connect them, and I'll tell you why in just a second. Just graph the points and leave them disconnected. You're actually not supposed to connect these dots because all you're given, this is called discrete data, and that's a vocabulary word from Algebra 2, and it's discrete just means disconnected. There is nothing in words that says that every single time you plug something in, you get something out. Over here it said every single input value is had, and then we add 1. So there's an infinite number of inputs. That's why we connected the dots, okay? This was continuous, where this one is going to remain discrete. So if you want to make a little note, discrete. It's just 5 ordered pairs. So we're finished with that. Then there's some vocabulary you need to understand before we go to the back of the page. Very, very important vocabulary we're going to be using throughout this chapter, okay? Increasing, I think, is going to be pretty easy for you to spot. Increasing just means as the input values increase, the output values increase. So you're going to be kind of on an upward slope. Decreasing means as the input values increase, the output values do the opposite. They go down, they decrease. It's going to seem like a downward slope. What you have pictured here is a linear situation, but you can have increasing and decreasing situations that still have curvature, and you'll see that on the second page in just a second. So let's talk about words that you may or may not have heard in your Algebra 2 class before. Very, very important, concave up and concave down. We call these concavity. Concave up is kind of like a smiley face. Concave down, you can think of it as a frowny face. But I want you to look at this very important verbiage under here because you guys are going to have to get used to free response questions. I'm going to ease you into that. But they are looking for very specific wording from you to give you the points on a free response. Concave up always means that the rate of change is increasing. I will explain more of that next week in 1.2's lesson. Concave down means the rate of change is decreasing. I will explain more of that next week. But it's in your notes not only today, but also next week. So turn the page and let's just kind of see if we are comfortable with the vocabulary and spotting little intervals from a graph. Our task here, we got this kind of funky looking graph, and it says the graph of h of x is shown above. Use the graph of h to find the open intervals, and that just simply means you're always going to use soft brackets. There's been a lot of debate online between AP pre-calculus teachers, and the consensus is keep everything open in pre-cal. For you, that just means use soft brackets, use parentheses. You might have practiced using hard brackets in previous math classes. Keep everything open right now. So we're going to find the open intervals where h has the following behaviors. So we're going to list every single interval where h is increasing. So here's where my colored pens kind of help me out, okay? I'm going to kind of sweep left to right, and starting at this point, I'm not increasing, I'm going down, and then I kind of hit this point and I bounce up, and I start right there, and I'm increasing. Going up, going up, going up, and then that's the point at which I start going back down, decreasing again. I'm still decreasing. This funky little corner thing, I'm still decreasing. And then right here, at the bottom of the scoop, I start increasing again. So what I've drawn in red, I need to be able to write those intervals down as the answer to A. So here is how you tell me the intervals. You tell me the x values. Well, that increasing interval right there started at -2 and went all the way to, look at the x-axis, 0. So h is increasing from -2 to 0. always use parentheses. That's not an ordered pair, that is an interval. So things can be a little tricky. All right, and then over here, I started increasing from 4 all the way up to 7. Look at your x values when you're listing intervals. So you're listing the interval for the input values, 4 all the way up to 7. Those are the two intervals where this graph is increasing. Okay, so decreasing. Let's do part B. Starting over here, I'm always going to sweep left to right. I'm decreasing there. It looks from -4 to -2. And then I'm also decreasing starting from 0. I'm still decreasing, I'm still decreasing, I'm still decreasing, I'm still decreasing, all the way to 4. So there's also an interval of decrease from 0 to 4. Now let's switch vocabulary here and let's look at where we have a concave up situation. So where does the smiley face start and end? And you can see this one kind of makes it obvious. It's going to start right here at 2, and it's going to go smiley all the way to 7. From 2 to 7. That's the only interval where this graph is concave up. You really can only talk about concavity when you have curvature, not straight lines. Okay, let's put two together. Increasing and concave down. So you can kind of start to see how we would mesh these two ideas together. Increasing, so it's got to be one of my red zones. And which red zone is concave down? Which interval? -2 to 0. Right here, I'm increasing and concave down from -2 to 0. And the last one, both decreasing and concave up. So I've already looked at my decreasing parts. That's kind of my, I know it might be hard for you to tell, but that's like my turquoise here. And I'm looking for concave down. Oh, concave up, thank you. Concave up, so smiley face, but also decreasing. Where do you guys think that occurs? From 2 to 4, very good. And if you weren't really sure of that when your classmates said it, look, from 2 to 4, you're decreasing and you're like the left part of the smiley face. Very good. Okay, the hardest part of this entire lesson is being able to just draw when you're given directions, being able to draw the graph. This is going to feel really awkward, and that's okay. I'm definitely going to use pencil because the perfectionist in me, I kind of like to erase and clean things up a little bit. So let me show you how I do this. I start with my increasing and decreasing intervals. It says, all right, we got to sketch this. K is increasing from -4 to 1. So here's what I do. I just kind of draw increasing from -4 to 1 very lightly. And it's increasing from 5 to 7, so I just kind of draw really lightly increasing. It says it's decreasing from 1 to 5, so I'm just going to lightly draw that in. And I've got my idea that I'm going up from here to here, down from here to here, up from here to here. Then I'm going to go back and add some curvature because it says now, additionally, the graph is concave up from 3 to 6. So, gosh, okay, that's like from right here to right here, I'm going to be concave up. So, smiley face. And it does not have to be pretty. Concave down from -4 to 3. So, frowny face from here to here. And you can be working anywhere in the plane. I like to kind of stay close to the axis. You could be floating way up here and do the same kind of shape. And then concave down from 6 to 7. So I'm just going to change concavity from here to here, but I'm still going to be increasing. And that's it. I really suggest you start by kind of sketching out your increasing and decreasing zones or intervals, and then just go back and add the curvature to it. It makes it easy. So here's what we're going to do. We're going to switch gears and we're going to look at the activity, which just think of it as more practice, because these notes didn't have a